Aside from the moving iron gauges that we have in these cars, we have what I refer to as thermal gauges. This is a thermal gauge. Now, the backbone to a thermal gauge is a device called a bimetallic spring. And here's how it works. Imagine a strip of metal, and this particular type of metal responds when it gets warm. It will expand when it gets warm, okay? So, and there are metals, of course, that will do that. Now imagine another bit of metal about the same size, which does not want to respond the same way. It does not have the propensity to want to expand as much. Now bond these two pieces of metal together. And what will happen is, when these two pieces of metal bonded together are exposed to heat, this one is going to want to stay where it is. This one's going to want to grow, and what will happen is it will form like that. This one will try to grow right around that one. And we get a physical motion by exposing heat to this bimetallic spring. Inside the gauge, you have this small piece of bimetallic spring there, and the wire, remember this power goes into the gauge and out of the gauge. As it goes into the gauge, it goes around and around and around and around and around this bimetallic spring. At the other end of the system, we have a sending unit. If we have a lot of resistance in the sending unit, in other words, she's at one extreme, the wire that's going around and around and around the bimetallic spring will have very little current going through it, no heat will be produced, and everything is just fine. But as the current changes, because the resistance changes in the sending unit, more current will go through, more current goes around. As current goes through the wire, of course, it creates heat, and this will be to change. I have here, this is a bimetallic spring right here. This is out of an automatic choke, but it's big enough so that you can see it. I've got a heat gun in my hands, and watch what happens if I put a little bit of heat on that spring. Can you see that? So it works very, very well. So that's how these systems worked. As the temperature would change, the spring would change, and she would go. As you saw even here, the gauge moved slowly. These are free of the business of having the gauge jump up and down or left and right when you hit a bump on the road. However, this system has a weakness. If you've got these two pieces of bimetallic spring bonded together like that, and you've got the coil of wire going around, and we've got variations of what the resistance is going to be, and we're going to have variations in electricity, this system will have more electricity going through it at some times than others. For example, when the car only has about 12.5 volts, you just turn the key to the on position to see what the gauge does. Okay, 12.5 volts, a certain amount of electricity will go through, a certain amount of heat, and the gauge will read a certain way. But if you start the car, and you have 13, 14, maybe even 15 volts, that's going to put more electricity through this coil. This will get hotter, and I'll get a different reading. We needed a way to find a way to stop them from doing that. The solution is a device called a voltage stabilizer, and this is what it looks like. This is a 131-555. It's for negative ground cars, and it works very, very simple. This side here is connected to the battery or the charging system in the car, okay? So whether I've got 12.5 volts or 13 volts or 15 volts, that's what's in here. Out this side, only about 10 volts comes out, which means that irrespective of what's going on in the rest of the car, only about 10 volts comes out of here, which means that my gauge, irrespective of what's going on anyplace else, has the same voltage all the time, and the readings that she gives are going to be stable. This is terrific. The gauge isn't swinging around anymore. She's dampened the way she's supposed to be, and yet she's going to be active and accurate despite the voltage throughout the car. And that's what these do. They work very, very well. A tip which I'll put in here, sometimes we'll get a phone call and somebody will say, I bought a brand new one, I bench tested and it doesn't work. The reason why it won't work on the bench is that this gets its ground from the frame when she's bolted into the car. So if this isn't grounded into the car, it won't function. But I promise when you put it in the car, it's going to work just fine for you. In our next video, we'll talk about how to diagnose potential problems in the system and find out if anything is wrong.